All right. We should be live. Looks like my yeah, looks like we were a little delayed on the stream. I'm not sure why. There is a delay between what my computer is sending out and what we're doing here, but it is what it is. Oh, that's because, of course, I just imported that, so that's normal as a warning. Okay, hello everyone. We'll see if we have viewers coming in. This is a bit of an ad hoc stream. I'm mostly recording this for people who want to look at what we're doing later on, and hopefully some people will come in. First of all, for those who celebrate it, Merry Christmas, and for everybody else, Happy New Year, I guess. I'm not very good at these sort of Christmas greetings and stuff like that. So, I figured I'd do a bit of an ad hoc stream today. Was talking a lot on the XR channel for quite a bit of time around the difficulties people have in placing the player in a VR world. And that is because there is a structural difference between how you handle your player character in a normal game versus how you're doing it in VR, because we have this competing system where on one hand we have the movements that are player induced by controller input or by the necessities of the game itself, and we have the movement by the player actually moving physically, taking a step forward, walking around the room, moving their body around, etc. And that causes a lot of confusion. Now, out of that whole discussion, there has been this opinion that keeps coming up about people wanting to use the player or control the player in a similar way to how you would do in a normal game. And that is, we want a kinematic body that we can move around without having to worry about the whole XR environment. Hey, Squarebag, how you going? Now, that's a challenging thing to do. It's not really that hard in principle, I guess, especially now that I've given it some more thought about how you could potentially do this. But it has a number of flow-on effects. So today's stream is about, first of all, looking at our standard setup that we're doing, having a quick, brief look at what the real problem is, and how we currently solve it in XR tools. And then we're going to throw that all away and we're going to build something from scratch and seeing if we can make it work in a different way and sort of see what sort of challenges we run into. Now, there's different ways probably not going to end up in XR tools. The biggest thing with XR tools is that we want it to be a library that you plug into your solution. And this approach requires you to do things in a set organizational way, which may not apply to all sorts of games. Hey, Malcolm, how you going? Well, Malcolm would probably know what I'm talking about because we've been talking about this extensively, well, today and over the past weeks. By the way, also, should be, actually, that's actually a good point. I always forget what the URL is for some reason. GitHub, Godot VR. All right. And I'm getting used to Windows 11. My machine, that's the other thing, by the way, my machine is running really poorly at the moment. I am not sure what's going on. Might be the heat. It is extremely hot here at the moment. Well, for my doing anyway. So also, if there's fan noise in the background, I am really sorry. Hopefully the what you call it? Hopefully the noise gate sort of filters it out. But Yeah, I do have a cooler running behind me just to make it manageable. Okay, so one of the things that I really dislike is that we don't actually have a link to it here, because this is the old current whatever documentation everybody is aware of, but there is actually a new one. And I have to think real hard where that one is. Is that on something like docs.github? Okay, Malcolm, give me some help. What's the URL for the new documentation page? For whatever reason, I never remember it, which is a bit of a problem, I guess. It should come up here, which is really weird. Squareback could very much be thermal throttling, but it's also because I think my laptop is slowly dying. God, what is the? Because it's not in our pull request for some reason. No, it's not. Come if you die. God. Actually, can we even paste URLs in chat, Malcolm? I don't know. And of course, I turned off Discord, so. Well, once I have the URL, I'll come back to you guys with that one. But there is a new URL for the documentation. We actually need to put that in our README. I think we need to have a link here to the new documentation page. Put me on the spot and go wrong. Yeah, links are probably filtered in chat. Else, yeah, you can send it to me on Discord. I got Discord on my phone, so and then because it should autocomplete, because I will go to it all the time. For whatever reason, I just always forget the bloody URL. Let's see. Here we go. Oh, you're right, buddy.
I'm good.
Godot VR. Why does that not autocomplete? GitHub.io/Godot XR tools. There we go. So it's organization.github.io Godot tools. So here's our brand new beautiful documentation page. It should be merged right now, right? Because I've only looked at it in the PR. Yeah, so concepts, PR origin. So yeah, Malcolm just wrote this morning. So I advise everybody to have a read through that one as well. This gives a little bit more background information about what we're talking about today. Anyway, so when we are looking at the whole scenario in our world, I'm just this is just my OpenXR test project for Godot 4. I am in Godot 4, by the way. Just doing this in Godot 4 today, just to keep things simple. That's that I'm doing most of the things in Godot 4 nowadays. But the same always, of course, also applies to Godot 3. So that should be nice. Anyway, this is our standard setup, right? I'm just going to hide those things. So we have our XR origin, which in Godot 3 is our AR/VR origin. So some of the things have been renamed in Godot 4, but they're still the same objects, which represents our tracking center. Then we have our camera, which is, obviously the eyes of the user. And then we have two hands. And these are, they're actually XR controller nodes, but they don't add anything new to the properties from XR Node 3D. So that's why we see Node 3D at the top here. But yeah, they're both XR controller nodes, and they track the controllers. And obviously, if you actually have trackers like these lovely things, you might actually have more things in there. But the principle here is, did I close? No, I didn't. So the principle here is that when you look at the player being in a room, that origin point is actually the center of that tracking space in the room that maps to that. And as our player moves around, our camera and our controllers move around the room, and we track there. So when we look at that, and for this, I just quickly imported our good friend GD Quest Mannequin, which of course comes back like that. Why do you do that to me? I don't want a jump. I just want a bloody T-pose. Thank you. There we go. So let's go and move that guy so that this actually makes sense. There we go. Boom. Boom. So this guy, where's my? Yep. So basically, as long as we put our camera on where our eyes is, because that's where our camera is, right? Basically, we actually have two cameras in the background, but we display it as a single one, which is nicely between the eyes. So that's where our player is. So now you can see with that camera position, we're actually off the ground. So let's go and put our player on the ground, because we're mimicking, we're mimicking a real world player. So let's say that this is a real guy. We don't have any information in the tracking space about where the person is. We only know where their eyes is. So if someone's crouching, we actually go like that, right? So we don't know. We only know that position of where the person's head is and the direction that they're looking at. We don't even know whether someone's, twisted their head around and is looking sideways. We're just making the assumption that the person is not just looking in the direction, but also facing that direction. And that's the thing that XR Tools does for us. It tries to figure out where the player's body is and how high, whether the player is crouching or not. And there's a lot of things that we can do there. Anyway, the point being, when we're moving through the world, when I'm actually walking physically in space, all that I can see is actually that, our players move somewhere. So all I know is that this is where my camera position is. Now, pretend that my hands would have moved with me. I'm not going to adjust all the nodes. I'm just focusing on the player at the moment. But the camera is positioned to where the headset actually is, where the tracking, the VR tracking determines where the headset is within space. And if my player keeps moving around, he just nicely walks around physical space. But what is important is that our origin point at this point doesn't change. And that is our reference point. That is the center of our tracking space, and everything is tracked in relation to that. All that we're doing right now is we're getting new tracking information from the XR system, and we are updating our player position. Now, the problem is that a lot of people are having trouble, because how do you now move the player around within the player's world? So with the tracking system, the player can walk around to the size of their room. At some point they're going to hit a physical wall, or they're going to hit a desk, or they're going to hit a sofa or whatever. So if this guy wants to, whoops, wrong thing selected. Getting ahead of myself here. No, you. So if this guy goes and walks over to, that's the wrong one. Whoop. Walks over to our basketball hoop here. And this is where in, his real world, his tracking space ends. He's about to walk into the wall. He can't move into here. So we need another form of locomotion in order to make the player move through the entire world that we have. But we can't just move the camera forward. That's what people want is, okay, I just want to move the camera here because now my player's here. Well, at that point in time, the tracking system is going to say in the next frame, oh, person has moved over there. So I'm going to put it over there. Yeah, but I want it to be over there. It's always going to update that position to the latest tracking position. And that is because the tracking isn't iterative. It doesn't say the player has physically turned 3 degrees or has physically moved 5 centimeters forward. It says, this is the new location of the player according to my tracking space. And how he got there, I don't care how he got there. That's just the new data. And it's the same with your hands. And that leads to a whole bunch of problems, not just moving the player around, but also, for instance, okay, what if the player takes a step forward and moves through a wall in my virtual space? Now, I don't have any walls here. We're going to have to add a few of them in a minute to test things. But in theory, the player could walk through a wall. And we don't want that. We want to be able to react to that. But because he now already is at a new location, we have a problem. So there's a bunch of different aspects to this that we need to start solving. Moving the whole wall thing for later, because that's a more advanced topic. Right now, we're just purely looking at, okay, how can we make our mannequin or our player move through the world? The only way to do it is to actually move our XR origin point. Now, the problem that we have here, movement is pretty straightforward, right? We can figure out the direction that the player is looking at, and we can move in that direction. Now, I can't right now because I don't have the coordinate system options, but let's say, for argument's sake, that our player is looking dead ahead that way. I can move my origin point that way to move our player forward based on controller input or any other sort of input that I want. That part of it is pretty straightforward and easy and is relatively the same as in normal games, with the difference that you're actually moving a point that's at some distance away from the player. Again, one of the things that people do get wrong is if they want to prevent the player from walking through a wall through controller input, is that they also put the collision shape here. And they're actually trying to see if the origin point walks through a wall, not whether the player walks through the wall. So imagine there being a wall here. Well, I can move my origin point forward without hitting that wall, but the player still walks through the wall. So that's problem number one, is, yeah, we can move our origin point around, but we still need to do collisions based on where our player is. The harder one is rotating. When we're rotating the origin point, we're also rotating the player's position. Because again, the player is not at the center of our origin point. It's wherever our tracking space is. So if our player was there and we want to rotate the player, we actually need to do two things. We first of all need to rotate the origin point, and then we need to move the origin point so that the player is back in the position they were at. And that trips up a lot of people for very good reasons. Now, when we look at, I'm gonna go and put this back where it was. There we go. Now, when we look at XR Tools, the way that XR Tools does this is we have this helper node called PlayerBody. And PlayerBody is a scene that has a bunch of things internally, logic, but also a collision object, so a kinematic body, and has a bunch of settings. So we can see that we apply a bunch of things, such as figuring out the size of our capsule that we use for collision detection. We have a distance from the camera. So one of the things that we do is, if the camera is here, we actually move our point a bit backwards, because we're not centered on the front of our head. We're centered on basically where our neck is. So we want to move that point backwards somewhat and see that as our center point of our player. So it has, the eye forward offset is how much the eyes are forward. So that's how much we move it back. And the camera to top head is the distance between this and the top of the head, which is used for calculating how high our player is. I keep forgetting that one. Sorry, mix that up. Anyway, This is actually a test version of XR Tools that I have here. That's funny. Okay. So our logic in player body now knows where the center of our body is. And all our movement functions, so we have our direct movement function here that allows us to move around the world with our joystick, interact with that player body and therefore know how to move the player around. So it actually puts the collision shape at that calculated position, and it then tests for movement from that. The same thing with rotation. When you rotate, and I believe this is still the old version, it actually has the turning in direct movement and the new one that's split out into two functions. But when you rotate, same thing. It will do the calculation to make sure that the origin point isn't just rotated, but also moved in order to make sure that the player stays in the space or in the place that the player is, and instead rotates around the player. So that is the basis of how XR Tools uses that, and I can easily fill a whole video detailing out exactly how we do that internally. We're also thinking about doing some enhancements soon that you can actually control that through methods on the player body, so that you can really use the player body to control the position of the player without having to worry about the whole thing that we've just been talking about. And likely that will remain the solution in XR Tools, because the nice thing about this approach, like I said before, is you can have a standard setup and you can add functionality from the XR Tools library as you need it. So for a game like this, where I'm walking around the world, I want to use this logic. But let's say that I am making a space simulator, flight sim or a racing game. I might not want that because I'm not walking around my car. I'm sitting in a seat. I want that, player to stay in the seat. I want to have a different way to deal with this scenario. But I still might want to use a lot of the features that XR Tools has to offer. So we're very conscious with XR Tools to keep a system that's very additive and that doesn't require you to do certain things unless it is needed for a very specific logic, like the player body needing to be there for certain movement functions to work. So there's a principle behind how we are organizing XR Tools. However, as an exercise to see if it would work, and maybe offer it as a solution at some part in XR Tools, because it does have some advantages. For these type of games, it would make much more sense to have the kinematic body as the parent node. Now, again, if we now have the kinematic body as the parent node and XR Origin 3D as the child node, if we rotate the kinematic body, we're therefore rotating the origin, we're therefore rotating the player around the origin point, and we're back at our problem that we have here. However, if we build it as a self-contained system, we can negate that. And we can make sure that our kinematic body is actually at this position. And we'll quickly mock that up to explain what we're going to try to accomplish. So for that, I'm actually going to gut a whole bunch of things here. I'm going to gut out all the stuff that has to do with our friendly... I'm losing my hands. I think I do want my hands in here. And here we can see that this is indeed an old version of XR Tools, because they are the old-fashioned white hands. We have really nice hands in OpenXR now. So I am going to put my hand back. There we go. This might actually still be the hands with the wrong offset. I'm not sure. I think so. Let's see. No, I've got the offset inside of the hand here. Okay, that's cool. All right. So yeah, we're gonna keep the hands just so that we have those visualized, but we're removing all the other logic from XR tools. I'm gonna keep my mannequin in here, but we're gonna move that in a different position in a moment. But for now, we're gonna keep it there just to show what's going on. So let's add. Oh yeah, that's not called a character body 3D. Let's add that into our scene. Boom. Cool. That's fine. And I'm going to change our XR character underneath here. Boom. So that should still be nicely 0, 0, 0. I'm not going to worry about the fact that we have the camera in the wrong spot. We are going to be working on that in a minute. So our character body is going to be nicely over here. What we also want is a capsule. Oh, a mesh. Now a collision shape. There we go. And we're going to add a capsule shape to that. Boom. And we're going to make sure that, let's go back to that 0.4 radius. That's good enough. We're going to make our player 1.8 meters high. We're not going to worry too much about whether the player is actually that. That's also one of the nice things about this solution is while we will be changing the height eventually, it's not as precise or needed to be as precise as oh, sorry. So we're gonna make move this halfway up so that it's nicely on the ground. There we go. We've got our player capsule properly. All right. Now again, for the moment, I'm actually gonna hide my hands for now just to get started, just so that that doesn't get confusing. Because again, we're not moving everything. Let's move our camera back to where we want it to be. That's right. That does need to be the right heights. So again, right now we don't really care about how high it is. Again, our mannequin is just for illustration, right? Our mannequin is not part of this. Hey, Luke, thanks for that. All right. So what are we going to be doing now? Because again, we've introduced the same problem, right? If we do have our player move over here, and if we would now rotate our kinematic body up here, we have a problem. So what we're going to want to do is, let's say that this has happened. Let's say that the player has moved to this spot. Now, just to help me, I'm just going to, this is just for visualization, just for me, myself, and I. Oops. Let's make it a bit smaller. I don't need it to be so big. All right. So just for my my ease, I'm just going to put that where our player has right now moved to. So what we're going to attempt to do now is we're actually going to attempt to move our kinematic body to where our player is. And as it moves, we're going to do the inverse movement on our origin point. So first thing is rotation. That's the easy one. So our player has now rotated. Let's actually make that a nice 45 degrees so that we can, do something proper here. So that means that we're going to rotate our player body by 45 degrees. But now we're going to counter rotate our origin by, oops, that's the wrong field. No. 0. Did I do that same thing on here? No, I did do that. The right field there. So I'm going to counter rotate our kinematic body by minus 45 degrees. So now our kinematic body is facing the same way as our player. One thing that I'm actually going to do here, can I? Let's get a second mannequin in here. That should not be on there. I want that to be on here. Let's actually move that all the way down here. There we go. And of course, this guy again also starts in the freaking wrong setup. So we want this guy to be like this. Now the important thing is that this guy is always facing the wrong way. So we're always going to rotate this guy. Why is it? Oh yeah, that's because we had it under. Okay, that makes sense. Okay, that's interesting. That is interesting. That one was okay. Let's start over because I think I mixed up my rotations. Sorry about that. So, okay. So the reason I wanted to do this is that we can now see our mannequin. And we are going to place our mannequin nicely in the middle. So that's where we want it to be. Cool. Now, can I? Probably not. Can I? Let's see, body. Okay. Sorry, guys. I just want to set this up just to make it easier to see what we're doing. So I think this is the original blue. So what I want to do is I actually want to make this guy transparent, alpha. And whatever that blue is, I'm not going to get close enough, but I don't really care. But the thing that I wanted to do is I want to make this guy transparent. So just so that we can see that's where we expect this guy to be. All right. So that's that one. Now, this might actually be our... No, that's our black, because everything black has now become white, I think. So again, alpha. Yeah, that was indeed our black. So that goes to black. Also goes transparent. Perfect. Okay, and then our last one is actually our white. Not shaded material, standard material. Thanks, Babs. Same thing again. We're gonna make him alpha. We're gonna turn that down. There we go. All right. So we have our mannequin to represent where our player actually is, and we have our mannequin to see where we're going. I'm actually wondering if I should not have done that the other way around. I'm gonna make these guys the other way around. Sorry, guys. Okay. Oh. Sorry, that wasn't smart. I should have reset. This is a little trick to make sure that it actually gets to the same position as the other guy is. So boom, that guy is now there, which now means that I can move him there. I can move this guy over here. I need to reset everything again. Okay, there's reason to my madness in a minute. Okay, so the reason I wanted to swap that around is our transparent dummy now shows where our actual player is in the world, while our opaque dummy shows us where we think the player currently is in the world. So now we can properly move him, and now I can correct my mistake from what I did a few minutes ago. This guy's actually rotated minus 45 degrees. So we need to first rotate our character body minus 45 degrees. So now we see that our player is facing the right way, but our real player has moved too far. So we counter rotate. Sorry, that needs to be plus 45. We counter rotate our origin point. So now, boom, our player, we still know where he is. He's still in the place before. He's still facing the way that he was before. but we've rotated our character. Now, generally speaking, we can rotate our character without needing to do any collision tests. But that might be something a little, dangerous to say, so to speak. All right. Now, to move the player forward, we're going to do the same thing. We're going to look at, okay, how far forward is our camera? Now, unfortunately, this is obviously in our local axis space. But we're just going to visually do it. So we're going to move our player forward to where our player was. And now we're going to move. And this one's very much more difficult because I don't have that as a axis requirement. But, well, I could, I guess, see how much we've moved this guy forward. So 77 minus 77. Okay, so we're going to counter that one. So this becomes minus 0.77. And that becomes 0.77. I did that wrong, didn't I? Oh, because it's got the rotation in there already. How nice is that? Okay. So that's interesting. What am I doing wrong? So this guy needs to go like that. Right. So we'll move there. So why is that? Because this thing is already rotated? Oh, so that is 45-degree rotated coordinates. Okay. It's funny that way. So it's probably, we can actually make that one 0, and that one would be something like 1.2 or whatever it is, somewhere in the middle of that. It doesn't have to be exact science. I'm just trying to explain the principle here. So whenever our character moves forward, we're going to, and we're not using the, we're basically using the local movement of origin to camera. We're going to move our character forward by that much, and then move our XR origin back by the same amount, resulting in the player being in the same position again. And in this way, if we do that in code, we can keep having it follow. So we obviously need to script that. And the nice thing is, I'm going to make that a tool script so that we can actually see it happening live in our demo. Now, one more thing that we want to do here, and this is unfortunately not something I can demonstrate in a tool script, but which we will enhance in a minute, is if we go back to where we were before. So I'm going to go put this guy back to 0. I'm going to go and put this guy back to 0. All right. Let's say, and I'm actually going to create another little thing for this. Why did I make that I didn't want that to be there. I want that to be here. Pull that wall. I'm not actually going to make this a proper wall yet. I'm just using it for illustration right now. There we go. That needs to be up. Actually, that needs to be up by 1 because we need to make that guy 2 meters high. Boom. Let's, just for argument's sake, say that there's a wall in between here. And again, when this is really happening, we're doing this every frame, so the movement of the character is very small. There is a potential of a numerical drift, but in this case, I don't think that matters too much. We'll have to figure that out because that depends on how much we use the movement in global space, because that's eventually what we end up doing, right? We're going to use the camera position in global space to then calculate what the body position in global space should be. And then we're going to compare that to the actual location of the player body, because that's really what I want to get to here, right? Is where the player is moved forward through a wall. We now have two options. Actually, let me complete that thought first. So we're calculating that global space. Then we're calculating how much our player body needs to move in global space to get to where the player is right now. And then we negate that movement on the X or origin point so that our camera should end up in the place that we expect. If there's a numerical drift there, then that will kind of be captured in the next frame, depending on where the numerical drift is. If the numerical drift is on the movement of the XR origin, it will kind of solve itself, because again, we're comparing those things. If it is on the XR origin, on the player body itself, it just means that the player's moved, you know, a fraction of a millimeter too far or not far enough. I think that part of it will not be a big issue. Mind you, that might be the thing that will eventually break this solution. Who knows? Anyway, I just wanted to discuss the situation of when we have a wall here, that we really have two options. Obviously, we can just ignore the wall and just move through, but that's not something we want to do. But we now will move the player, and the player will hit the wall. So the player is now not moving as far as we want the player to move. Now, when we look at our current solution in XR Tools with player body, what we're actually doing in this situation, or what ends up happening in this situation, is that the player, did I just move the wrong one? Yes, I moved the wrong one. How good is that? So this one I need to move. Don't worry about that. Or did I? Maybe I did. Can I have that little slider thing? Yeah. So what we do right now in XR Tools is we actually move this guy over here. So if you walk into a wall, when you physically take a step forward and you walk into the wall, then you get the sensation as if you're being pushed backwards. And now with a wall, that's not really such an issue, but it's especially an issue if this is actually like a desk and you're trying to move over the desk. You're actually running into the desk, and that's stopping us from moving the player body forward. And as a result, we're pushing the player back, which can be really annoying if you're trying to grab something on the table just outside of your reach without moving your head forward. And that's still something that we need to solve in XR Tools, by the way. The other option that we have is instead is if we move this guy forward. Now, I didn't really measure how far we moved him forward, but that's, oh, let's say that's about 0.2. We can move him only backwards the other way around. We can move him only backwards by that amount. Oh, yeah. So now we can see that we're back on our square where we were before. Now, in this case, the player has moved through a wall. Now, as far as our game is concerned, our player is still behind the wall. They haven't moved through, but the actual player has gone through the wall. Now, again, keep in mind that in a real game, you wouldn't be making such a big movement. Unless you keep walking forward, obviously. You could end up in this situation. However, we would detect that we would be moving out of the location that we are at. And we could, for instance, black out the screen or do some other effect, as long as the player is a certain distance away from the player body. you know, we can put some rules there about what we do allow and what we don't allow. Now, another part of this equation is that we're using a single capsule. Obviously, if you really want to go to advanced VR, you know, for instance, the situation of our table is that you would actually bump the legs against the table and not allow the legs to go forward, but allow the player to actually bend to a certain amount. So there are a number of solutions to look at those sorts of edge cases. Again, that's way too much for what we're going to deal with today. We just want to get the principle of this working. But you know, that would allow you to at least not ghost if you're bending over the table. Of course, you know, we can be lenient that we can move a certain amount into here without blacking out. But the thing that obviously we want to prevent is that if a player has moved through a wall, is that they get insight of what is in the next room. You know, think about the situation where we're doing a spy game or where there's enemies hiding in the room that you're about to enter. You know, someone could peek through the wall in this way, which is, you know, a problem that a lot of early VR games had, where, yeah, by physically moving through a wall, the game couldn't stop you. Or, you know, do what XR Tools does right now and push you back, which tends to be nauseating. Anyway, that's one of the things that we do need to keep in mind that we want to fix at some point. So let's remove our wall for now. I just wanted to show that as an example of something that we need to look into what we're going to do there. All right. So let's see if we can start scripting this and see what we can do with that. And that's going to actually be interesting because I wonder if I can make this as a tool script, because I would be moving the dummy around, or actually I would be moving my XR camera around while Godot keeps trying to reverse that. We'll see what it does with that. That's going to be interesting to see what it does there. So let's go and actually let's go and save our character buddy first. Do we want to do that? No, we're just creating a script on this for now. And I'm even going to create it in the root. Why not? And I actually don't want the default character buddy. Do I want that actually? Yes, I do want that. So I now have UI control of my dummy. So this is player control through the normal way. Oh, and this is actually where the changes to move and slide are, because in Godot 4, move and slide doesn't take parameters anymore. You actually set state, but we now actually want a different state for moving our character body as a result of physical movement compared to moving for this, which actually is fine. We can make that separate. That's pretty cool. Yeah, Malcolm, that's basically what we're doing. We're using move and slide to move the player body to where we want the player to currently be. And then we are negating that movement in XR origin so that the camera ends up back where it was before we move the player. And that way the player body is always, you know, this character body is always representing where the player actually is, except for that scenario that I just sketched. If you hit a wall and now the player is actually allowed to physically move beyond the wall, but the player body stays, you know, where the wall is. All right. Yeah. Cool. So this is, in physics process, we're actually handling our normal movement. Now, this is the other problem, is that we really are supposed to do move and slide in the physics process. For Godot 4, we can actually do that. That's right. For Godot 4, we can do this. Because the main difference between Godot 4 and Godot 3 is that we actually update our tracking data in Godot 4 before physics process. Unless if you run physics process in a separate thread, that's really the more annoying scenario. Yeah, I think that wouldn't have drift. I think that will correct itself on each frame. So as long as the movement sort of matches up, even if the movement isn't precise, it should be close enough. Okay. Process on player. And of course, I'm being dumb because I should just do that over there. Of course, I'm going. So all I'm doing here is that the code that I'm getting by default from Godot. This is one of the things that I really like about Godot 4 is that we have these code snippets that we get for free. I've just moved that into process or player input. Now, when we are looking at our input vector here, which we are now doing through keyboard input, which for our test right now is fine. Obviously, we want to replace that with input from our controllers. And we would have to have some way for the controllers to feed that into here. That is something that I'm not going to deal with today. I just want to look at the player movement purely from a how do we get the character body to represent the actual location of the player. That's fine. Godot 4 format production. Luke, that really depends on where you are right now and what you're building. For XR, if you are looking to release something in the near future, I would stay with Godot 3.5. The XR support in 3.5 is stable, works properly on headsets like the Quest, and you have the advantage of libraries like the XR Tools library, which is fully implemented for Godot 3. When you look at Godot 4, all the basic logic is there, but we still are having performance issues on the Quest. XR Tools only works for about 90% at the moment. There are still parts of it that don't work properly. But the thing that you get as a bonus is that there's been a lot of improvements in the XR system and in Godot as a general. So, yeah, basically, yeah, Godot 3.5 is a safe choice. Godot 4 really depends on how comfortable you are working around problems and whether you're actually looking to release something soon. If you're still like 6 months to a year away before you think you'll be finished with your project and wanting to release it, Godot 4 becomes a viable option. But if you're looking to finish your project in the next 6 months, I would stick with Godot 3. I would not go to Godot 4, especially on XR. For normal desktop games, you might make that decision a little sooner, especially if you're purely, targeting PCs and you're not targeting consoles or anything like that. Then Godot 4 is a good bet to already go on. That's why a number of developers are now already switching to Godot 4. But I think for XR, it's too early if you. If you're looking to release in the next 6 months, or if you're not comfortable working around the shortcomings. Okay, so Malcolm, the problem that we have with the Pico, supporting the Pico in 3.5 in theory is not hard. There's two things that need to be done. Actually, three. The first thing that needs to be done is there is part of the initialization of Android has been changed for Chronos that Pico uses. which never made it into 3.5 because the Quest doesn't need it. So that there's code in Godot 4 that can pretty much be copied over to Godot 3.5 for that. It's not a big deal. The second issue is the controllers on Pico, and that the controllers on Pico are not yet part of the official spec, which, you know, is actually easier to solve on 3.5 than on 4 because no, Pico 4. I'm not sure. Is there a Pico 8? Pico 8 is like a little chipboard, isn't it? No, the Pico 4 is a new headset coming out of China, which is close to Quest as far as what it can do and what its capabilities are. So the second thing is the controller settings, which aren't part of OpenXR yet. Now in the 3.5 plugin, we can just add them. Who cares? But in 4, we can't commit those changes because we can only include things that are open sourced, basically. And right now, the only place where you can get the official Pico bindings and the little bits that need to be in there, they are part of the Pico SDK, which is a closed source SDK. Yay! So yeah, so there's a little little issue there, but that's not a big one. But the big issue for 3.5, the one that we solved in Godot 4 but haven't solved in Godot 3, is that you need a different loader and you need different settings in your Android manifest files. And that means changes in the Godot 3 core in order to support the Pico manifest entries, which is a pain in the butt. Now you can go to custom builds. So if you do install Android build template, you can do those changes manually, and then you could build a version of the Godot 3.5 plugin that has the Pico loader in it instead of the meta loader. And in theory, and I think someone's already tested it and said that it works, but in theory that should get you 3.5 support. Now, that's all practical, right? What needs to be done in order to make the Pico run in 3.5? The real struggle that we have is we're basically down to having a different Android plugin for Pico from Quest. Not very different, but different. And we don't have a deploy mechanism for that. We don't have a way to say, if it's meta, use this plugin. If it's Pico, use this other, binary part of the plugin. So yeah, annoying little problem. It's definitely solvable if someone puts the time in. Yeah, it does require a couple of changes. That seeing how far along we are with 3.5 and that 3.5 basically is in a point where we don't want to do major changes to the export system. That's a bit of a struggle. Well, Luke, it would help if I actually stream a little bit more regularly and actually put some videos up more regularly, but I've been so busy this past year. This last year has been absolutely crazy, both on a personal level and on a professional level. Then unfortunately, my YouTube channel has suffered a little bit. I just haven't had the time to make the videos that I wanted to make. And that's how YouTube works. If you don't put out content, if you don't put videos on, you don't get the subs. And hopefully at some point I will. I will have time again for doing proper things with my YouTube channel. And, right now we're in holiday periods. It's a little bit easier to flip my priorities around a little bit, but that's only temporary. Okay, so we have our default scripts. We're gonna use that for now, even though I might rig in something for the controller input. Not quite sure yet. But for now, that'll do. So you'll see that I have actually moved all that logic into a separate function that I'm now calling from physics process, and that is because I now want to add in a function that does our player movements from as we discussed from moving our XR origin point. And I want to do that for two reasons. One is to isolate the two different solutions so that it becomes easier to see where what happens. But the other thing also is that if we can't move the player's body to where the player is, or if we can't move it far enough, we actually want to disable the player input here. We don't want to be in a situation where I've walked through the wall. I'm now actually on the other side of the wall with, maybe grayed out or blacked out or whatever. And now all of a sudden the player turns and my physical player sort of snaps around, suddenly gets on the right side of the wall, and suddenly I teleport like a meter or two forward. Don't want that. We want to force the player to return to a position where they are no longer inside of a collider or move too far ahead before we get player input. Again, that's where we want to end up with. We're not going to do that right away, but that's where we want to end up with. That's something that we want to make sure we do. The other thing is we don't need delta inside of, do we not? No, we do need delta actually, because we need to do a trick with delta. That's because we are using actually velocity here. And velocity is in meters per second. And move and slide actually applies our delta inside, which means that we need to we need to look at our movements and then calculate back what that is in meters per second, so that it then turns it back into the actual movement that we want. It would be nice if we we didn't have pure velocity based movements. We would want to do a move and slide just to a location. Actually, maybe we need to use move and collide, or that might actually be a better idea. But I wonder if move and collide will go up slides properly. Well, Malcolm, I have half the video ready for dealing with picking up objects and stuff like that. And I really want to make a push at making some videos around XR tools, and hopefully that is definitely something that maybe I should focus on this week and next. Officially I'm not fully on holiday, but I am sort of on holiday, sort of not. So yeah, we'll need to figure that one out. Okay, so this one we're gonna go process on physical movement. So we'll call it that. And we're going to put that over here. Okay. And here we just need to make a backup of our velocity. Okay. Do we want to type that? Is that really important? I don't think so. It's actually really interesting, because if you already have a velocity forward. Yeah, I'm not sure if I'm as keen on the fact that they made this change on the velocity. It doesn't really matter. In the end, behind the scenes, it's kind of doing the same thing. Luke, absolutely. I am not an artist, and I don't claim to be at all good at that. And it is something that has definitely held me back on when you look at YouTube. And it's not just thumbnails; it's actually also when you look at the assets and things that I would need in support of the videos. It's one of the reasons why I've had ideas for a long time in how to make a video on this topic, for instance, and sort of show, what the issues of moving in VR are, and then getting stuck because I just don't have the artwork. which is, you know, if I grow and I get some decent income, I might at some point hire an artist for something like that. But for now, it is what it is. Okay, so we need to start having a look first at rotation. We're really going to make these things one by one. So first we're going to rotate the character in the right position, and then we're going to do the same thing to the my mind's not working today. We're going to do the same thing, or the movement afterwards. Okay, so when we're looking at that, we need to start with whatever way this guy is facing. And then we need to make sure that this guy rotates the same. So let's go and actually take all this out again so that we can use our little mock-up here to help us out with what it is that we're doing. So we can't simply take that, because again, we don't care about tilt, right? Whether the person is looking up and down. We don't care about rotation. We care purely about the forward direction that we're looking at. It's all that we're interested in right now. Yeah, APT might work for images, but doesn't really model anything yet. And you're not wrong, Luke. Many game developers are not that good at art, which is why I am so amazed when I look at people like Jitspo or oh, what's his name, Raphael, who are both just so amazing and being all-round devs, and not just being able to write code, but to just create these amazing pieces of art. And, you know, just a little plug for Raphael here. If you haven't looked at his videos, his channel, I think it's called Pixter. He has this amazing video online about the making of Franz Fury, which, interestingly enough, is a top-down 2D game that just looks very 3D, even though it's pure 2D. You know, obviously, he also made Beat Invaders, which is a full 3D game, which, again, is also, you know, talking to him about his development process for that, the goals that he set out, building that, and the way that he built it is just absolutely incredible. But he's got a making of, you know, a very early making of the video of Franz Fury, when it was just a game dev, game jam game. And to see the source material that he uses, and then ending up with this amazing looking end result. Yeah, my hat's off. I would not be able to replicate that. That's not where my skill set lies. Yeah, I'm really impressed by people who are able to wear both hats in that way. Now, I can model a little bit, although I haven't done it much in recent years. I used to be pretty proficient with 3ds Max, but again, just to create basic models, not to the level that some of these guys do. I'm pretty sure that if I really put my mind to it and put the time into it, I could probably get there, but all right, let's start with the rotation and make sure that this guy starts facing the right way without actually moving this guy in the wrong direction. Now, again, like I said, we can't really use that. Depending on the orientation of the headset, we might get some really weird results. But we do want to do it inside of, we don't want to do it in global space, because we don't know. This character body might be inside something else. Might be inside of a spaceship that's flying through space. So we sort of need to do it in local space, but we need to do it. Yeah, we'll get there. Hold that thought. About the player's head rotation. Yeah, we do need to, because again, we need to make sure that our character faces the right way so that we can do, because it's not just positioning, it's also orientation. Because again, you know, when you look at logic, for instance, like the existing logic here, which is actually using, you know, our direction from our base, and again, even here, it is local direction within the space that thing exists. So what we're going to do here is we're going to start with creating or getting our transform of a camera, but we're going to get it in local space of the character body, which means that we're going to be applying our Origin 3D transform to that. And actually, let's get that first. Get some about. So the first thing that we want to do is our origin transform. It's going to be a transform E, and that is going to be our. And in this case, you know, we're going to assume that we know that this is part of our entire structure. So I'm not going to worry about names. I'm just going to go and get the transform for this. Then we want to get our camera transform 3D. Of course. No, I didn't want that whole thing. Just that one, thank you. We're going to get that one. Might as well put that in here. I'm going to say camera. And I think it is this way around. I always wonder if I get that right. All right. So now we have our camera transform in our character body, in our character body's local space. Should I really be naming that character in Origin? I don't know. Anyway, the point being, now we can get our forward-facing direction. So for that, we're going to get our camera in Origin, faces.z, so that's forward-facing. Then we want to have our y negated to 0. Why? Oh, because I made a typo. That's why. And we're going to normalize that vector. Okay, so what we now have is a vector pointing forward that direction in our character body space. Which means that if our character body is already rotated, that vector does not. That's actually pretty cool, because that means that looking top down, if we're already looking in the right direction, that vector should be pointing in z minus 1. So that actually makes that we basically in a 2D space. We could just do per normal angle vector there. That actually makes it much simpler. That actually makes it much simpler. You know what? I'm going to make that we're just going to grab that as a vector 2. And we have an angle 2. Angle to the given vector in radians. Cool. All right. So I think we can simply do forward angle 2 Let's go and print our angle here. See if that works. Now, here's another problem. Process is disabled in the editor. Physics process is disabled in the editor, I think. Let's see what happens when we make this tool script, whether it's actually running. And just to be safe, I actually want to undo that one or comment out that one because it might actually be capturing input, which would be hilarious if that's the case. That probably isn't going to do anything unless we reload the scene. There we go. Perfect. Now that's filling up like crazy. But if we change the camera direction, oh, that didn't do anything. Oh no, that's because okay. So let's make our life a little bit better. Yeah, it might be. I don't know because it is the camera is applied first because it's always in reverse. So some transform is your camera and then more transform is your origin because you're starting with that, then you apply that, then you apply that, and then you apply that, and that you get you your global transform. So that's how the global is done. So that. So we do main times character times origin times camera times mannequin gives us our mannequin global transform. So in this case, we're doing origin times camera to get our camera global transform in the character body space. We'll figure that out once we start moving because with angle, you know, we can see that this one's negative. It's really cool. And that obviously keeps on going and keeps on going. Very cool. We know that it's a minus 45 degree rotation that we had, and that was indeed minus 0.7. So our angle looks like that it is the right way around, but yeah, we'll see if it stands up or if it falls over. And if it falls over, we just flip them around and see if that's the correct thing to do. All right, so we have an angle now. And with that angle, we want to rotate our character body and we want to counter rotate our origin. So we're going to start with rotating our character body. Now, this is the other thing. This is really interesting. Actually, we don't want to cache this stuff because we're going to keep making changes and we want to recalculate to see what the changes are as a result. Yeah. So you know what? I'm just gonna go and do this. I'm going to go and do that, and now I'm going to go remove those, and I'm just gonna put that over there. Because I think we're going to do that calculation a second time. Now, the other thing is we don't care about position in this. So we could make it even better by calling that camera bases, taking our bases, and we're actually gonna multiply our bases, which means that we no longer need you. We no longer need you. All right, we got you. So now we can go and let's do that after this. Transform. Vector 3 up. Angle. Okay. Now our origin 3D dot transform. No. Transform. Come on. Is rotated. What are you making, Mike? Smells good.
Huh?
What are you making? Smells good.
I didn't make anything. I just ate. I had beef jerky.
Okay. All right. So that should, in theory, work. Now let's see if that's still running. I can see that that is working fine. So as we rotate our camera, our character body is rotating, and our XR origin is counter-rotating. Cool. All right, now for movement. So now we do want to transform. Because now it's important that we actually get our origin transformed by that. And I guess I could, yeah, that might even be better. Camera location going to be vector 3. What we're actually going to do in this case is it already gets stuck on that, and therefore I can't look up the X form. What's it called then? Did I change that? Oh, that's now through operators. Okay. So that's just times. Okay. Well, it's X form in 3.5. It's times in here. So And again, that's going to be interesting to see if our rotation matrices are there for. Doubt this, never used, it's fine. Camera location is clear, but never. Okay, so it's happy with that. It gets a location, and whether it's a correct location, we don't know yet. We'll figure it out. All right. Now here comes something funny, which is why I probably want to disable this being a tool script just for now. And that also means that I'm going to want to reload that just to make sure. Hey, Bailey, how you going? Oh, yeah. Sorry. You mean like that? Keep forgetting, but yeah, my camera does get in the way. Am I going to port my space sim to Godot 4? I'm thinking about it, to be honest. I'm actually thinking about picking that up again. I haven't touched that for a year. And I kind of miss it. So yeah, I'm actually thinking about getting back to the space sim, and moving that to Godot 4 might actually be a good idea. So now we know where our camera location is in relation to our character body. However, we need to move that back to get the center of our Okay. We are going to add a helper for that one. Yes, we are. We are going to add a helper for that. Yep. What we're going to do here is, do we still have? No, we don't. That's just going to be called an O3D. Boom. I'm going to put that over there. Obviously, the mannequin is only for our testing right now. That's not part of our structure. That's where I'm kind of thinking that I should be doing it differently. Okay, hang on one second. I do want to do this because for the sake of reusability, we're actually going to create a new scene. Okay. That's broken. Lovely. All right, let's add in a new kinematic. No, character body. Yes. Okay, so we're gonna go and call that player. There, we're gonna go and say that does work. Interesting bug, that one. Okay, so I'm going to actually create a folder for your body. And I'm gonna save that in there. All right. Let's move you up. That wasn't quite where I wanted you. Where are you? Where did you go? Where did you go? Into one of these. There we go. That was dumb. I want it over there. Cool. Boom. All right. So. Let's go and clear you out for now. Then we're going to go and move you into player body. We're going to rename you. Body. Okay. Inside here, we are going to go and load. Shouldn't have doesn't really matter. So then here we want to have our XR origin. We want to have our XR camera. We're going to have our XR controller. What did I call that here? Left hand. What you unhappy about? Because that needs to be here. Okay. Right hand. Okay, so that's going to be our right hand tracker. We're going to keep that on aim. That's going to be a left hand tracker. That's going to be on aim. Perfect. Cool. Now, what we want to do is we want to make editable children. Boom. You're going to go away because we're going to recreate you in a minute. Then here, okay, before we do anything else, we need to make sure that these are all resets. Our script is no longer a tool script, so that's all cool. Boom, boom. Don't care about any of that. Yes, I do. I want to go do that. I want to do that. I want to do that. I want to do that. There we go. Perfect. So everything's now back to normal, which means that our offset here is good. Oh yeah, that's the other thing that I needed to do. Camera. Oh, I did that a little bit too much, didn't I? So fine. Get that default position. Again, these don't need to be precise. They're just helper locations. And I will be checking this into a GitHub page just for helper's sake. Okay, so now what we need to do, let's go and hide you for a minute so that we can see what we're doing. Okay. So that is correctly positioned for that. Okay, let me get my helper. I want you to go back to, oh, no, not that. Transfer 0, 0, 0, boom. So that's a center point. Okay. All right. I'm just going to move this guy. No, I'm not going to move that guy. Sorry, guys. I'm just thinking about. Transfer. What are we getting? 1.6. Okay, so I want this guy to be 1.6, not 1.8. Again, that's just to have our dummy go in the right position. Do I put my helpers in a global singleton? No, not all of them. Well, I might put them into singletons, but I'm not putting them all in one big one. I like to separate my things out to the category that they're in. So, for instance, in XR Tools, we have an XR Tools singleton that contains like our main settings and stuff like that. I also like to keep as much information as possible in my scene tree whenever I can. Depends a bit on what I'm doing. Anyway. Okay. I just want to put my mannequin nicely on the center here. So that when we now look at our transform here, we're 185 away from the middle. Okay, so I'm going to do that. And again, everything that I'm placing here, oh, not the origin, the camera. That's 185. Everything that we're doing here is purely to help us visually, all right? All these settings are going to be overwritten the moment that we start playing our game. They're going to have actual tracking information. But I like to place my camera and my hands in logical positions to make it easier for someone who's looking at this to see what's going on. So we're going to reset that to exactly where it is. Now our mannequin is slightly into the ground, but for purposes of today, that doesn't really matter. Again, our mannequin is just, again, a visual aid to help us to see if we're doing the right thing. All right. So now we just need to move the remaining bits. So we're going to move our left hand over there. We're going to move our right hand over there. We're going to double check. We can see that actually we have different spacing. Oh, I've got them in 1 meter instead of 1.5. I actually would like to change that. Why did those go to 1.7? Did I accidentally have... I don't know. Okay, so I'm going to go put that on 1. I'm going to put that... Oh, that one I just put too high. Okay, that makes sense. All right, which now means I can go and put that one on 0. And I can put that one on 0. And they are now in the correct spot. Very good. And that's the other thing that I want to do here. I want to make sure that we separate out the things that are part of our player body system into a subscene, and the visualization parts, the helper parts that we're currently doing, we will have ended up in here. Okay, so this can all go. Let's go and delete that one already because we're not really using that. Let's just collapse that so that we can more easily see what we're doing. That needs to go in there. That needs to go in there. So this mannequin no longer needs to be forward because we've moved. Oh, where is that going way forward like that? Mannequin, rotate it 180. Okay, that's interesting. Did we? We did, didn't we? Okay. Okay. Hang on a sec. That's on 0. So our mannequin is there. That is slightly there, so that's an eye height. Right. And that's back by 4.8 because of where. So this should be the same. No, it's not. Why not? What am I doing wrong here? But does that really matter? Can we just position it so that it matches up? Because that is actually pretty much what we want. Yeah, that's fine. Okay. So we now have a collision shape back. We have our character nicely in the middle of a collision shape. Perfect. We have our camera there. So now the thing that we want to do, and again, the exact amount that this needs to be forward doesn't really, that's something that's settable. We're just going to use our mannequin as sort of getting a baseline. So now we can do a node 3D head position. Okay. And that one we actually want to then make the exact opposite of this. And we could move that eventually down if we want to, do more of the body thing. But we just have that as a setting. Now this guy, we probably want to have as an export var here. Going to find it. Actually, I want to have that after my consts. Export. So mixing up my Godot 3 and Godot 4 syntax there. I offsets. It's going to be 0.185. That's new value. That's new value. And now if is inside tree, we're going to go and do, actually, I do want that to be an unready var. And we can say head position from the origin is vector 3 0 0 I offsets minus minus I offset. All right. And we probably want a ready function here as well. Just going to repeat that. Normally I put that into an update function, but yeah, let's do that. There we go. So now that's a value that we're not going to play with, but again, I'm just trying to sort of complete the thing, and that will now allow you, when you use the player body, to change that head position. And we could do some visual things to make that nicer, but I guess we could, but maybe not now. Okay. Because one of the things that I would think of is also moving the camera forward as a result. Again, just to complete that visualization of what we're doing. Do we want to do that? Yeah, we might actually want to do that. So we're also going to do an on ready for camera. Actually, let's name that node. Just to, this camera is one of those names that you would often reuse. Your camera node, so we can go and do stuff like this. Make life a bit easier. I'll do the same with origin in a minute as well, but for now, let's do that. And here, what we're going to do is if is ever probably an engine or something. Okay, what is it then? Editor is editor. Okay. Combination of everything that I tried. Here we go. So if we're in the editor, we're also going to do camera node dot transform dot origin. Actually, you know what? Just gonna do point Y. And you know what? We'll also do that. Sorry, dot Z. We're also gonna do that over here. In the background, it still does the same thing. It construct that, but this way we don't have to worry about any other offsets that we apply. All right, now we've got our tool mode off right now, so obviously it's not going to do anything, but this would allow us to get that offset. Now we have our head position node. Unfortunately, now we do need to go and make that a proper conversion. Yeah. And in that, you might be right. You might be right, Malcolm, that we are doing our transforms in the wrong order. Because it makes sense to be able to do origin node times camera node times head position node dot transform dot origin, giving us and that now becomes our player body location. And this means that if we are looking up or down, that position will be closer. We are actually taking our up down in there. And if we do that when testing, that would make our mannequin be in slightly the wrong position because we're not rotating our mannequin around. But it does make sense as far as the player body position being. Because again, you think about it, when you're looking up, your eyes actually move back. We don't want to then move our body backwards. When you're looking up, we want the body to be in the same position. So, and for that, it probably means that our head position actually needs to be where our neck is, right? But I don't want to go too far with this setup. But that is something that we really would like, or would really want to do at some point, is make sure that. And actually, I'm going to reload this guy. There we go. Is now we have our head position, because that one we actually want to have on our neck pivot. To be exact, we could argue that it should actually be there. And maybe that is true. Maybe we've actually moved our mannequin too far forward because we're using our feet position. But we could argue that it should actually be there. All right. For that, let's go and re-enable our tool mode. Why is that still? Yeah, that's right. We don't have a collision shape because that one is set over here, which is fine. Maybe our collision shape should actually be in our player body. Yeah, it could be something that we want. Yeah, we probably want that to move. We'll do that later. For now, I just want to go over here. All right, so that has doubled up somehow. Okay, have we also got that doubled up here? No, because that's still open. So why did it go like that? So our head position transform is indeed still minus. camera is forward. Okay. Hold on. It's the other way around, isn't it? Yeah, it's the other way around. Okay. How funny is that? I got that the wrong way around. Okay, so now, yeah, that's done the right thing right away. So we can start playing with this one now. So if let's actually go and hide our auto mannequin. And our head position now, so that's nicely there. So one of the other things that we want to do is we actually want to move that back down. But first I want to find a good center line for this. I kind of really want it to be there. Or do we want it to be there? Where are we? No, I think we are actually swiveling on this. So at 0.1 might actually have been good. There. So with the head position there, but we probably want to move this one down a little bit. Minus 0.05. All right. That should also be a setting, but for now, 0. I'm going to just do that. We are also going to go and so 0.1 that we eventually came down to. So let's go and make you 0.1. So that now becomes 0.1. The reason why it's not working here, by the way, is we haven't reloaded player body since making this a tool script. Okay. So now go and undo that. Scroll. Is that still in the right spot? Yeah, perfect. So now our head position is nicely there. We are only now using that as a center position for our body. However, now you get that if I look up or down, imagine the head rotating up or down, the camera now becoming there. We are still positioning that that swivel point here. Now, obviously, this is... Hi, Symbiote. How you going? This is a guesstimate. We've only made the forward position settable. We really should make the offset settable as well. But for what we're doing right now, I think that's good. All right. Now, I think that also means that we can start moving our collision shaping here. Actually, let's go and delete this guy. Should have moved that in before. Collision shape. There we go. That now becomes a capsule. Back to being 1.8. Nope, sorry. That needs to be 1.4. This becomes 1.8. Thank you. And then this can be 0.9. Now our capsule is back top. Perfect. Okay, which means that we can now go and show him again. And make sure that he's actually positioned there. So we know where he is. All right, cool. Sweet. Okay, cool. All right. So the other thing which is really nice is because we have everything now in a subscene, we can move stuff over here without it actually changing that. And we can start moving things around. So let's say that he's moved there. Rotation is now working, but the movement isn't yet. Perfect. That's a funny shape inside the head. Okay. So we've got our rotation working. We now need to make our movement working. We now have our body location. Now, again, in this case, I am really wondering if... Okay. let's go and do this. This is where adding test stuff really works. Where are you? What patch? Why am I not finding that? Okay. And what we're simply going to do now is test dot transform origin. All right. All right. So all right, we can see that our box is nicely in our head, which means that it is indeed being positioned where we should be. So that could mean that Malcolm is absolutely right. No. That actually means that that's really weird. So we have our transforms in the reverse order with the origin at the end. Because in GLSL, you actually start with the vector, and then you do them in reverse order. That's really interesting. Okay. Anyway, we've pretty much proven that that is what it should be. Well, have we? Because, oh, no, it doesn't. Because we haven't moved the origin yet. So let's just, for fun. Yeah, so our box keeps being in the right position as we are moving everything, which means that we are correctly locating that location. Because remember, our test is not a child of the origin node. So let's reset this so that that is back where it was. All right. Cool. Perfect. Okay. So now it's time to move our player body to that location and our origin back. However, we want our player body to okay, we need to use our global transform for this. Because again, we're going to use move and slide, and move and slide. Does move and slide work globally or locally? That's a good question. Move and slide. Does that work? Moves the body based on velocity. If the body collides with another, that should be in global space. So why then is this working in local space? Are they assuming that your player body is always local? Or, sorry, always global? That's interesting. Because again, we might be childed to something else, like a platform or something like that. So I'm not sure about that. I'm going to get out on a limb and thinking that in this case, I want that to be global, and then obviously, oops, sorry, that needs to also be global for tests. Okay, let's put that to the test, shall we? Let's add a node 3D in here. go here. So we're purely doing this for testing. Move that as a child to that. So now, I actually want you to move here. Oh, wait. That also means that I want my helper to be here. Oh, cool. Not that my helper is in the right position at all. That's interesting. It's not at all in the right. Actually, you know what? I'm going to get rid of that one because that one doesn't make any sense anymore. So yeah, so now we're going to go do this, and we're going to go do that, and we're going to go do that. Just to make it extra complex, that, you know, we have our player childed to something else, and we want to make sure that the movement is correct. Now, I bet that keyboard input is now going to be wrong, because keyboard input isn't using global space, which would be simply fixed by changing that to global transform. That's my theory, but we're going to leave that alone for now. But I'm doing this on purpose to make sure that our logic works properly, because move and slide, as far as I'm aware, works in global space, not in local space. I could be wrong about that. Now, the other thing which I'm not sure of is whether move and slide works inside of the editor. We might get in trouble with that. Let's just see what happens. Oh, the other thing is, because we now have our... Oops. Our player here, our player here, if we move a slide to there, we would actually get a continuous movement forward. We have to make sure that we do the back and forth at the same time. But again, we're only testing here, right? All right, so I also want to I want to remember our original position so that we know how much we've actually moved by due to the movement slide. And also, until we actually have this finished, I'm going to turn off being a tool application. All right. So we want to move our player to the new location. Cool. That means that our velocity is now going to be our new location minus our old location divided by delta. Because our movement is the movement that we want to do in one frame, and the duration of our frame is delta. So we want to translate that from the movement from one frame to a movement per second. Right. Now we should be able to do move and slide. So let's go and leave that there because that's our test. Now we actually want to, oh, hold on. That's not entirely correct. Because we obviously now want to remove the Z out of this. Sorry, the Y. We don't want to move up or down. We just want to move to that general location. All right. Okay. Actually, I'm going to take that out. I don't care about that anymore. We've proven that that is right. So we no longer need you. Now, in this case, we're going to see how much we need to move our origin point back by looking at how much we actually move. So in this case, we're going to do our delta move. It's going to be this guy minus our original body. Seeing we want that in reverse, I'm actually going to apply that in reverse. Makes it easier. Now we want to take out, again, our vertical movement, because we might be going up or down the slope. And we don't want to sink into the ground. And now we need to actually get that in local space, which is going to be interesting. So now our delta movement is going to be origin node dot global transform dot. Why does that not autocomplete? Inverse. We could actually do a fine inverse even if we want. Not sure why that didn't autocomplete. Anyway, now our delta movement should be in local space, which should mean that that we can just apply this to the XR origin. I wonder if we got the math right. I'd be surprised if we did this right the first time around. Well, and else our character probably is going to be flying off. If it even works, because, like I said, ooh, our character has flown off. Okay. I'm not. Okay. Cool. Oh, it doesn't like... Oh, once it's none, it's getting... Oh, yeah. I thought I said already said save. Okay, let's just reload this guy. Okay, player buddy. There we go. It's our origin. Okay, there we go. Cool. All right, we got that wrong. Okay, now is that because we can't do move and slide? How can we do this? How do we test this properly? Actually, I don't need to do this. Because I can just do that. That's... All right. Oh, hold on. That definitely needs to be like that because we're working in global space, which will not work if we're on a slope. Um, yeah, that's safer. Because now if our offset node is on a slope, which is going to be important if we're indeed on some sort of moving platform or body, then we're still going to do our move and slide in local space, or effectively in local space. Now, again, this is assuming that move and slide isn't already going to global space. That's because that might actually be our problem here. Move and slide. Okay. It's a shame. It's not really very well documented. So, um, let's first try this. Global transform. Let's rule out move and slide. So we're just gonna move this guy to where it's supposed to be. So he should now just move over there, or fly off into space again. One of the two. That's so sad. Okay, might have to reload. Everybody's there. The orange is back there. Okay. Oh. Well, that would have proven that that part of it works. Okay, so this is still not rotating the way that it should. Why not? Okay. That's weird. What did I screw up? And that might actually be, that we indeed have these the wrong way around, right? It's very possible that that's our problem. Yeah. Okay. Let's see. No. Unless that's a loading problem. Okay. So player body is here. Origin is set to there. Camera's here. All right. What am I doing wrong here? Okay. I think our problem is, and this is really dumb. Okay, that's absolutely my mistake. I'm going to turn this back. The reason this is going wrong is we're rotating the player body. So we're rotating the player body around, but because our origin point is now here, we're now counter-rotating our origin point. We actually need to rotate our origin point around here. Which is the exact opposite problem that we're having if we're working the other way around. So this bit is fine. That bit is wrong because now our origin node is no longer at the right place. So we're actually going to do this a different way. Origin node dot transform origin. This is a really let me think. Actually, this would probably work. Very dirty. I think that will work. No, doesn't work. Okay. What mistake am I making here? So we want to counter rotate. in 3D. It is. The 3 up. Mm. So. Oh, what? Okay, hold on. Of course, everything's now in the wrong spot again. Because we want to rotate this by a certain amount so that it faces the right way. And we're going to counter rotate this one. So am I just doing this the wrong way around? Maybe I'm just doing this the wrong way around. I actually don't get, why is my mannequin? That doesn't make sense. Hold on. Wait. Wait. I know what I'm doing wrong. I'm rotating the entire transform. I'm not rotating the bases. Ah, that's why. That is why. Jeez, I'm so stupid. Because I only want to rotate the bases. I don't want to rotate the location. That's my problem. And I should be able to do then exactly the same thing on the origin node. I was wondering, like, the logic was right. Why was it not working the way that we were expecting it to? Okay, but this is still... And that is logical, because there it does make sense, because as I'm rotating him, I'm moving the XR. Yeah, and that is where I am doing that. Okay. So now we just need to figure out which way around this needs to be. Now we're working properly. Yes. Now we're rotating it in place. Cool. Okay. Now let's see if our movement code is also working. So now my player is following my camera perfectly. Sweet. With now my player body there and my origin being all the way over there. Cool. Ah, why the hell do we get these sort of guys? Boom. Okay, cool. So that solves that. Now we just need to find out, is our move and slide, did we just make a mistake there? Or is our move and slide just not working? Okay. So. For that, we need to make some bigger changes. Aha. All right. So. Cool. Let's go and really change these things up. We can keep that. We can keep that. All right. Now things get a little bit more tricky. Um, okay. Boom, boom. Okay. So that should size itself to our thing here. Viewport, sub-viewport. You're going to go over there. You guys are going to go over there. You guys are going to go over there. Boom. And then that, luckily, that is working. Okay, cool. Smart enough for that. Okay. Which means that we now here need to do, this is no longer an X, this is now going to be our HMD. That's going to get XR mode, so that's going to be whatever we're going to see in our game. Perfect. Actually was removed for this test. All right. Let's actually have a look. That is all sticking the way that it should. Actually, let's go and reload that. It's still working the way that it should. And eventually, I don't really want to keep this a tool script, but we shall see. Actually, all right. Yeah, we probably want to disable the Vega tool for now, so that we can actually reset everything. Or you know what? Oh, we had actually fully disabled that. Okay. So we can enable that again. Well, I'm going to be sitting anyway, so I can probably test that. We don't have any input actions, really? Yeah. Okay. Oh, show built-in. Okay, so we have built-in actions in there. Okay, that's cool. So those will work. All right, cool. Don't mind that at all. All right, let's first keep testing over that. So let's finish this. So the thing that I now wanted to do is I need to add a remote transform in here. Play buddy. And here I'm going to do just node 3D. Because the problem, of course, is that we have this split there. So that's going to be our player position that we're going to be updating. And we're just going to update them all. That's fine for what we want to do right now. And that will transform our player position to our output here, so that we can add a normal camera in here. And that one, we're going to do just a bit behind the player. Two viewports preview. Okay. So that we can see our player walking around, and that's then the view that we're going to be seeing on screen. And I'm actually thinking, yeah, that's no longer a tool. Actually, that should become a tool script again, but we're just going to say, just don't run our process in our editor. It was fun for testing, but I think we're at a point where we don't want that to happen, because things just go crazy if we do. Okay, that should also mean that I can now turn that back into the tool script again. Let's go and reset this, reset this. There we go. And then the same with camera. Reset, reset, reset. There we go. And now if we're in 3D, I just want to go on my normal view again. There we go. So our player is now, I see there now, our hands are floating in really weird positions, but that's fine. And let's just go and put that back to where our offset node is. So that's going to be our starting position. Yeah, our remote transform, that's going to put that there. Our camera is still pointing at our player. All right, let's see how well this works so far. Okay, that hasn't resized. That's interesting. Okay, we can definitely move our character around, but we can see that our shadow one is really weirdly positioned. And that is, of course, because my camera is... All right, so that's pretty cool. We can see that it's moving around with our camera. Okay, but moving forwards and backwards does not seem to move my character around. Well, it does inside. I can see properly. Of course, I'm sitting down right now, so obviously that's it. Okay, we're first going to fix the our container. That should be as simple as that's alignment. Fill. Let's see if that works. No, it hasn't done anything, has it? By the way, this is... Oh, these are off. Okay, that's why they're just floating around there. So yeah, now my hands are working as well. Very good. We don't have any inverse kinematics. That's actually another nice idea, is eventually doing inverse kinematics on this this character. Okay. Why is that not? Okay. Why is that not? Okay. This is weird. This is either not working as well. Okay, so that was just in there. So now that's full screen. All right, cool. Okay, one nice thing as well. Well, we can see that if I move my head, the whole player body moves around again. That was just, of course, just for us testing. So you might want to do something about that. But then again, we're just okay. I'm actually gonna not put that on my head because I want to see what's happening on the screen. Because I obviously want to see if I walk back. Yeah, I'm moving. But at the same time, I can move with my keyboard. Where's my... But I can also see that my movement is not taking my pivot or my offset node into account, as I was expecting it not to. So one of the things that we're going to do right now. Okay, so this is only movement. This does not actually do rotation. But I do think that that should be global transfer. And now we are moving in the correct axes. Perfect. There we go. I don't know if that's just because my camera is in a weird spot that you can't. Oh, that's because the person's isn't actually, the feet aren't straight. The feet are slightly offset, so it looks like it's not moving forward, but it isn't actually moving forward in the head position. That's fun. Kick the ball around. Because of course the ball is a physics thing. And also, okay, so that part of it all works. Other than obviously that I'm really crouching, and we should have done stuff like that. Okay. Let's see what we can do with the move and slide. Okay. I think we're getting really close to what this should be. Cool. What time is it? Oh, it's already 4:30. All right. All right. So let's just do this, and then do this, and do this. And see if we get the behavior that we expect, or if we're going to be flying off like crazy right now. Oh, that's working. So I think that none issue was because we were in inside of the editor. Now, also see that we still move our ball around. So that is still working. All right. So now, let's put up a real obstacle. Okay. All right. So we know that our offset thing works. That's cool. All right. Let's make a new static body. That's wall. No, you there, there. All right, so let's start by adding a mesh instance to our wall so we can see our wall. It's going to be a box. That wall 2 meters high, but we're going to make it a thin wall. That now needs to be 1 up. Let's make it a bit wider. Okay, so I do want that to be like so. Oh, no. If I want to move it, I need to move it with that. Okay, so now we need a collision shape. And that needs to be a box. And we want to size that the same. And we want to move that 1 up as well. All right, so let us see what happens now. So this is a situation where if I actually move my head, there we go, there's a wall. So if we do this with here, we're going to go and just not be able to go through the wall. But if I move forward, we can see that our body is trying to get in there. But we're not going through. So we're being stopped going in there. But we can see that, hey, we're not properly moving. Now I can still do that because we haven't got any protection there. Okay. Sweet. Okie doke. That's cool. I actually want to see what that looks like. Do I? Okay, so first thing that we're going to do now . Okay, so we now want to protect that if we're actually colliding, if we're trying to move through something, then we can no longer do player input. So if we're up against the wall, trying to get through there, then Now the other thing that we want to do, okay, for that we're going to go into our player body. We are going to add a new mesh instance to this. Go. That is going to be a quad mesh. Boom. Okay, that quad mesh is going to be moved forward a bit more. Boom. Right. We're going to make a new shader material. Boink. And we're going to create a new shader. And this is going to be, let's call it blackout shader. Why not? This blackout. All right, so here's our shader. Boom. Cool. Now, the first thing that we're going to do here is we're going to give this a vertex shader. And in here, to remember how this works. Position is vertex. Like 4. Like that. Yeah, like that, but also yeah, that was a backface culling issue. Okay, cool. That's interesting. Why? Oh, that's because we're still doing positioning. Okay, mode, unshaded. That should be automatic because I'm doing position. It should no longer. I don't get why that is not. Oh, that's why. That's why. I know now. Because it's going from 0.0 to 1. Is it? Let's see. Hold on. How big is my? That's why. Oh yeah, and that was correct. Minus vertex. And now it fills the whole screen. That's right. Because it needs to go from -1 to +1. And it was going from -half to half because my world size was not right. So this is something that always fills the screen. Yay! Oh yeah, it's very similar to what we are doing with the vignettes shader. So in this case, I just don't want the opening in the middle. I'm just going to black out the whole screen, but we might end up using a depth buffer at this point in time. Okay. But for now, I'm just going to start with no, fade, I'm going to put on that. Float is, okay, so 0 is that we're not seeing it, 1 is going to be full. So in this case, we are going to do alpha, and we're going to say is fade. Okay. Why is it? Oh, I'm mixing up GDScript and C or DLSL code. Let's actually for fun put it on half. All right, so that's now half see-through. I also want that just to be like that. Or are we going to do our depth buffer thing here? All right. No. We actually have a screen UV for this, do we? Yeah, I think so. All right. Texture. F texture. Screen UV. Oops. Okay. Cool. Now this is a problem because we don't really have anything in here. So I just save that. We should be now seeing that here as well. Perfect. Cool. We can actually make that 0.8 so that you can see this become much. Nope, the other way around. Is it? Okay. Oh. Okay. I do want that to be fade. So we've got some sort of. Okay, that also is. Well, always, I think it is. Actually, that's disabled. There we go. So why are we still seeing part of our mannequin? That makes no sense. It's so weird because. Oh, that's because part of our mannequin is actually rendered transparent because we're doing the transparent see-through thing. So I bet you that is this guy here. Yeah, that's that one, not that one. Which means that we need to have some sort of rendering priority on this. No, is that on the shader? Render priority, here we go. Okay, so this I always forget is that I'm positive. There we go. Let's see if I'm right. Because if I do that negative, where are you? You can go the other way. And then we get all the transparent things rendered on top. Cool. So that is how we can make sure that that is always rendered last. So I'm actually going to put that insanely high. All right, so there we go. Now, obviously, we do get these sort of things because they are rendered afterwards in our EDA. So here we go. We want our depth to be, actually, I want to go back to having this slightly transparent so we can see what it's supposed to do. There we go. All right. Now our depth. Do we want to unproject that? I don't think we really care. Okay. In what range does it start getting in there? Okay. Okay, what is that unproject function again? In this. I know that I'm looking at theory, but I'm not sure if the documentation has been updated for with what I'm looking for. Okay. So we got our death. Building texture for reading depth on screen must convert to linear using inverse projection. Okay. I did that. Okay. Okay, so hold on. Hold on, cool. That's something else. Dot Z. So why am I getting a uniform color here? Unless my depth texture, of course, isn't working. Are we? which is probably what the problem is here. Render, yeah, we are. All right. I think that's likely my problem because the resolving of the depth texture is not working in the. Ah, Malcolm's figuring it out. Very good. Come on. There we go. All right. No, still are not. Don't tell me that they changed to this the other way around, right? No. Pretty sure that's not it. That's not it either. Yeah, I have a feeling that we have a broken depth texture at the moment. Hey, don't do that. That was from before. Okay. I don't actually really care about that. Just care about that. What am I missing here? Oh, really? No, that shouldn't be the case. Because we're reading from that. Okay, I bet you that that one is. Oh, there we go. Okay, so we're just oversaturating. That was why that wasn't working properly. Okay. All right. I'm definitely doing something wrong with either reading a depth texture or we just don't have a usable depth texture. Or my screen UV is not working. That's also possible. Although that doesn't really make that much sense. Thanks, Gilzazab, and welcome. I don't think we're gonna go down this route. I'll need to figure that out at some point, but I do think that is a problem in the resolve of the death texture. But something that we will figure out some other day. Now, the thing that I don't get here, I would have assumed that to be a much stronger effect. Because at 0.9 alpha, I would have expected that to be very, very dark. Blend. That is the default, so I don't know. I don't think I want to worry too much about that. The important thing is that we're going down to completely dark. Okay. So going back into here, is what we're now going to do is now nicely, this should actually work in both. We shall see. I might have to make sure that the blackout only works. So we got all color masks here. Let's go and set those up. And say layer names 3D render. We're going to make that our default. That's cool. But then let's make this H&D only. And this one we make only. Which means that here we want to take off 11. Make sure that we don't see any desktop things here. And then in our desktop camera, we want to make sure that we disable H&D only. And one of the things that we can, for instance, do is our mannequin here. Here, layers. We actually want to put this into desktop only. We only want to see our mannequin on the desktop. Cool. And we probably want to do the same thing for this guy. We only want to see you on the desktop. We don't want to see that guy inside of the headset. Same way, our blackout one. We only want to have in the H&D. We don't want to black out this, what we see on the screen. Unfortunately, that doesn't mean that you guys won't see what I'm seeing. Although that's something we can solve because we can go and put a texture rect here. Okay. Import texture. Is this guy? Yeah, we are going to go and scale that one. on the minimum size. So here we go. Oh, what? I can't change the scale of that. More texture size, thank you. Okay. Blackout node. Okay, so if we're not colliding, we're gonna hide this guy. If we are colliding, oops, we're gonna show this guy. Go mesh. I don't know. Did we do the override? What did we do? Yeah, we did the override. Okay. Get surface override material for surface 0 if material dot set shader set shader parameter. That's going to be fade, and we need to make a fade. So black fade floats. Back. Okay, so this is how much we've moved. Um, mm, 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 mm. That's how much I need. How far do we go? Okay, our player body location is in global. Still have that. So if we subtract those two, we know how far away we still are. We get the length. Now that's going to be in meters. So let's multiply that by 10. So now we get, when we only, 0 at 0, but after we move more than 10 centimeters into the wall, we start blacking out the screen. And obviously we want to lamp that one. In 0, 1. Okay. Let's see if that works. Let's see how many mistakes we've made. All right. We are good here. So our preview isn't working, and I was expecting that because whenever you use, oh yeah, that's definitely not happy. Why is that still giving me errors? That doesn't make any sense. It's probably because of this. Yeah, it's because of TextureX trying to render. Another control parent. Yeah, that's fine. And what? And this. There. There we go. Okay. And the problem with this guy, and actually I'm going to go and clear the texture. Boom. And we're actually going to assign that in script. One of the problems that we have here is oh no. That's not a sub viewport. Let's just see if that works. Whenever you have your texture rec before the viewport is actually added in your scene tree, it tends to have a problem with that. Now, it's still not working as it should, because we definitely have that working. So, what are we doing wrong now? We're fine. That ought to be doing the right thing now. Yeah, that's working. Okay, that's not updated. That should work. This is these are the moments where I wish I had stuck with 3.5 because I'm pretty sure that we're running into 3.5 bug here. Well, I'm going to test whether it works anyway, because I can actually see in here. All right. Oh, that's interesting. My keyboard isn't working. Okay, so I bet you. I bet you that because we're colliding with the floor, it considers it colliding. All right. Well, in that case, we are not going to rely on colliding here. Okay. So distance is not. If distance bigger than, say, a centimeter for now, we are colliding. If we are colliding, we're going to do that. Do that. Oh. Well, you guys can't see this, but I can. I am now getting my screen nicely darkened when I try to move into the wall physically. Perfect. Now, obviously, this will go wrong if I'm just stopped by a table. But principally, it works. I can now walk up to a wall and then physically try to move into the wall. And first of all, it won't let me. The player body will stay outside of the wall. And second, my display will go dark. Now, I would like the depth thing to work, depth texture. But I think I'm going to have to do a little bit more research on that one and find out why that's not working properly. All right. Now, I no longer have any of that stuff working. Alrighty. I have to give this a name and say player body test. Test player body as parents. Yeah. Mine. Blake, I'll make dinner in a minute, okay? I'll make dinner in a minute. All right, so. Yeah, player body test has, so why do I not see it in here? Here we go. Thought so. All right. So anybody who wants to have a look at the source code, you can see it over there. I think I'm going to actually call it a day there. It is 5 p.m. here, so it's time for me to start making some dinner. Make my little boy happy. So, yeah, I hope people found that interesting. We got most of it all to work. I think it's actually a really nice base for a player controller in VR. And I might actually do a lot more of this. Might even turn it into an asset by itself. And who knows, Malcolm and I will have to have a talk and see if this is something that we want to do in XR Tools. Again, our feeling so far has been that because this forces a certain approach on you, that it does not make as much sense. However, it's actually a really neat implementation. This worked a lot better than I was expecting. So, yeah, I'm leaving it at there. I don't know if anybody's got some questions left. I will be putting this link in the description of the video. This video is going to remain on my channel for as long as YouTube allows it to be there. So, yeah, I hope everybody enjoyed this, and I guess I'll see you guys the next time.